Right, the Year 9, Term 1, Week 1 Advanced Maths Quiz. Put these numbers in order, starting with the smallest. Hot tip, if you are trying to order decimal numbers, it is in your interest to make sure there are the same number of decimal places in each number. You will be much more likely to get it right. This one here, the 0.346, has 3 digits after the decimal place, so I'm going to go back and make all of these have the same number of digits of 400, 300 there, 250 and 350, because now they're all expressed in the number of thousandths. Remember your place value, tenths, hundredths, thousandths. That's going to make it much easier to figure out. So now I've got negative 300 thousandths. Well, that's definitely going to be my smallest, followed by negative 250 thousandths. So I can automatically rule out A and B. The next smallest number, so I've got my negative ones, I now need to go to positive ones. 0.346, that's a little bit less than 0.350, isn't it? So I can see there, that's the difference between the final two, and I need the one with 0.346, then 0.35, and finally 0.4. So the answer for question 1 is C. On to our next question. Two different numbers are equal to 4.37 to 2 decimal places. So that means they've been rounded to 2 decimal places, and the answer would be 4.37. You know that anything that was 4.365, a 5 would tell me I had to round the 6 up to a 7, or a 6, 7, 8, or 9 there would tell me I have to round the 6 up to a 7. Anything greater than that number and less than 4.374, remember that 4 would tell me to keep the 7 as it is. Anything between those two numbers is going to round, if I round it to 2 decimal places, to 4.37. So I just need to check my answers and make sure they're in between there. 4.37, that one's going to work. 4.365, well, yeah, 3651. That 5 is going to tell me to round that 6 up to a 7. I think my answer's A. Whenever I get an answer A, I just quickly check the others anyway. Ooh, the top's going to be 4.37. No, 4.362. That's not going to get rounded up. 4.373, that one would be okay. 3.371, definitely not going to be rounded to 4.37. And 4.3751, that 5 one's going to tell me, if I wrote that to 2 decimal places, 4.38. So we're pretty confident we got it right, and we can move on, and it didn't take us too long to check that. What is 1.516 rounded to the nearest 0.05? So when they say rounded to the nearest 0.05, it means it's either going to end in point something 0 or point something 5. So here I've got 1.516. So is that closer to 1.50 or 1.55? And remember my little trick from before, if we write them to 3 decimal places, even though it says just write it to 2, this 516 is much closer to 500 than 550, and definitely the 6. Sorry, I was rounding to too many decimal places there. Yeah, rounding it to the nearest 0.05. 516, that's going to tell me, well, it's much closer to the 500 than the 550, so it must be 1.50 to the nearest 0.05. Definitely closer to 1.50 than to 1.55. It's a little bit trickier when you're not rounding to the nearest decimal place, but they're telling you to round to the nearest 0.05. A number rounds to 20,000 when it's rounded to the nearest 10 or the nearest 1,000. Oh, sorry, the nearest 10,000, the nearest 1,000, and the nearest 100. Which number could this be? So which of these is going to round to 20,000, whether I round it to the nearest 100? Well, let's just see, if I round this to the nearest 100, that's going to be 19,200. So that's not going to be it. This one here, if I round it to the nearest hundreds, that's my third spot there. Well, the 7's going to say to make that 20,100, so that can't be it. 20,043, if I round it to the nearest 100, well, the 4 says to keep that 0 as a 0, so that would be 20,000. And if I round it to the nearest 10,000, it's definitely closest to 20,000. So it looks like C is going to be the winner here. We quickly check this one, 19,949. Yes, if I rounded that to the nearest 1,100, well, it's going to be 19,900. So definitely can't be that one, so we know our answer was C. Expand and simplify. Just need to be careful expanding this negative. That's where we get into trouble with this question. So first up, the 4 multiplies the 2x. Remember, number times number, and then just keep the letter along for the ride. So 4 by 2 is 8, and there was an x there that it was multiplying, so it's 8x. Then the 4 needs to multiply the 1. 4 times positive 1 is positive 4. Not so bad. Now I've got a negative, and remember my distributive law, which is the law we're using when we're expanding, says to take this negative, and if there's no number in between it, that's a negative 1, and make sure I go negative 1 times 5x, and a negative times a positive is a negative. So that's negative 5x, and then negative 1 times negative 9, and negative times a negative becomes a positive, and 1 times 9 is 9. Now I just go ahead and collect my like terms. So my 8x minus 5x, that would give me 3x, and 4 plus another 9, that would give me 13. So I look through my answers, and that looks like answer B there. Tom and Katie are arguing about expanding these single brackets. Tom says negative 3 times 1 minus 2p is going to get negative 3, and negative 3 by negative 2p, so negative times negative should be positive 6p. Looks like Tom's done something sensible here. Katie says it should be 6p minus 3. Well, if we think about that, they're really the same expression. Katie's just decided to multiply the negative 3 by the negative 2p first, and a negative times a negative gave a positive 6p. And then she went negative 3 times 1 is negative 3. These are equivalent expressions, so they're both correct. They've both done it correctly. In terms of the order in which we'd naturally do it, Tom's probably done it in the natural order. But in terms of the order in which we'd like to see our answer written, usually we'll put our term containing a variable before our constant, and definitely if we can have a positive before a negative rather than a negative number and then adding a positive, it just saves on a symbol. Mathematicians like to be as efficient as possible, so we'd probably write it the way Katie's actually written it there. But both of them are correct. If you wrote it either way in an exam, your teacher would probably be kind and give you the mark either way as well. Another expand and simplify here. Remember, from our order of operations, we must multiply before we add or subtract. So my 5a, I'm just going to leave it at the start there. Nothing happens with the 5a. But I've got to take a negative 3. That negative belongs to the 3. So I'm going to go negative 3 by 2. So a negative times a positive is a negative, and 3 times 2 is 6. Then I've got negative 3 times negative a. A negative times a negative is a positive, and 3 times a is 3a. Did I say a negative times a positive before? Was it positive? I hope I said a negative. You can see I've written it correctly. That's the main thing. 5a plus 3a. Remember, adding my like terms, I'm going to have 8a minus 6. There's my answer there. So double checking there, 5a, I had a negative 3 times a positive 2, so a negative times a positive gave me a negative, and 3 2's was 6, and then the negative times the negative gives a positive, and 3 times a is 3a. Then collect your like terms. Flying through these, what does this simplify to? Well, it's already fully simplified. Remember, we can only add or subtract like terms. That means terms with exactly the same combination of letters. This one here, it's a 2d squared. And the next term, the term separated by the plus or minus, is 3d. d is different from d squared. They're not exactly the same, so I can't add those terms. So none of the above is the solution there. This one here, we can simplify it. The 6g doesn't have any other g's to simplify. But if I have negative 2 h's, and then I get positive 1h, so negative 2 plus 1, well, that would get me to negative 1. So my answer is going to be 6g minus 1h. Of course, we don't usually write the 1 in front of the h. So again here, the answer is none of the above. It's tempting for many people to go, oh, here I've got 2h, there I've got another one, there was a negative there, I'm going to have negative 3h, but that's not the case. This is negative 2h. I'm adding 1h, so 1 to the right of negative 2 on my number line is negative 1. That's not one of the possible answers, so I choose none of the above. Simplify w to the power of 4 plus w to the power of 4. So when I'm adding like terms, I just count up how many of them I've got. Here I have 1 w to the power of 4. There I have another one. Altogether I have 2 things that are called the very strange name w to the power of 4. But you're just counting up how many there are. It doesn't matter that it's an unusual name. The procedure itself is easy. Alright, solving an equation. We're pretty great at solving equations, you guys. 5x plus 1 equals 2x subtract 11, or minus 11 if you like. When I'm getting my x's together, I want to get them on the side that already has the majority of the x's. I've got 5x over here. So I want to eliminate my 2x's from the other side, so I subtract 2x, which means I subtract 2x from the left as well. If I'm getting my x's on the left, I don't need this 1 over here, so I'm going to subtract 1. That's the opposite of adding 1. So I'm going to subtract 1 from the other side. 5x minus 2x, I'm now left with 3x, negative 11, take away another one, negative 12. And then the opposite of multiplying by 3 is to divide by 3. So when I divide the left-hand side by 3, the 3's cancel, I'm left with just x. And negative 12 divided by 3, I'm sure you all did it in your head and you could have gone straight to this line. X equals negative 4. And there we have it. Question 12. What is the value of the following expression, negative 4 squared? I included this one because your calculator will lie to you unless you're careful. If you just type in on your calculator negative 4 and hit the squared button, it's going to give you the answer negative 16. But the answer to this is not negative 16 because it's saying take whatever r is and then square it. So I have to make sure I take all of r. r is negative 4. So I have to have negative 4 and square it. Remember, squaring is multiplying something by itself. So I've got negative 4 multiplied by another negative 4. 2 negatives make a positive, so the actual answer here is 16, or C. So that's basically highlighting there's a difference between negative 4 squared, which we just had above, which is 16, and negative 4 squared without brackets, which means I've got the negative number 4 squared, which would then be negative 16. If there's brackets around the negative, including the negative, then I'm multiplying a negative by a negative, it ends up positive. If there's no brackets around, that means I'm squaring first, and I'm subtracting 4 squared, which is why I end up with negative 16. 1/2 divided by 6. Division is multiplication by a reciprocal. Most of us know this when we're dealing with fractions, but sometimes we get confused when the thing I'm dividing by is just an integer, like the number 6. If I've got a half divided by 6, I can just think of that number 6 as 6 divided by 1. That would still be equivalent to the number 6. Now you're all familiar with division is multiplication by a reciprocal. The reciprocal, of course, turn that fraction upside down. I've changed the sign to multiply. Then you go top times top. 1 times 1 is 1. 2 times 6 is 12 in the denominator. And so my answer is 1/12. Good little bit of fraction work. We're going to get very comfortable with these, but we just need to practice them as we go. Tom and Katie are arguing again, this time about equivalent fractions. Tom says 9 over 15 is equivalent to 12 over 20. Katie says 9 over 15 is equivalent to 15 over 21. Who is correct? Well, let's write each of those fractions in simplest form. So Tom, let's start with his 9 over 15. You look for a number that goes into both 9 and 15. That's obviously 3. 3 goes into 9 3 times, and 3 goes into 15 5 times. So 9 over 15 is exactly the same as 3/5 if I write it in simplest form. Let's check the 12 over 20. Well, they're both in my 4 times table. 4 goes into 12 3 times. 4 goes into 20 5 times. So 12 over 20 is 3/5. It looks to me like Tom is right on this occasion. Let's have a go and look at how Katie's going here. She has 9 over 15. We already know that's 3/5. What about the 15 over 21? Well, 3 goes into 15 and 21. Remember the little trick, if you're not sure whether 3 goes into a number, just add the digits of the number. 1 plus 5 is 6. We know 3 goes into 6, so it will go into the whole number, 15. 21, if you're not sure if 3 goes into that, you just add the digits. 2 plus 1 is 3. 3 definitely goes into 3, so 3 must be a factor of both the numerator and the denominator. That means I can simplify. 3 goes into 15 5 times, 3 goes into 21 7 times. So that fraction, 15 over 21, is equal to 5/7. 3/5 is not the same as 5/7, so on this occasion, only Tom is correct. Right, next question. Which decimal is equivalent to 1.5%? Well, this is a little bit tricky because I've got a fraction here, but they're asking me to answer in a decimal. You're best off in this situation to write 1.5 as a decimal first. So that's 1.5%. Now, percent means out of 100, so if I just want to write that as a regular number, out of 100 I've got to divide by 100. 1.5 divided by 100, when I divide, my decimal place moves to the left. Yes, people will argue that your decimal place actually never moves, it's the numbers that are moving, but the effect when you write it is that you'll see it end up 2 places to the left. So I should have 0.015. So my answer there is going to be answer C. Moving on to the next question. Question 16. Which of these fractions is equivalent to 66%? Well, we just talked about percent meaning out of 100. So if I want to write something that's a percentage as a fraction this time instead of a decimal, I write it as divided by 100. Now all I have to do is simplify that fraction. They're both even numbers. 2 goes into 66 33 times. 2 goes into 100 50 times. Oh, now I've got 33 and 50. They're not sharing any more common factors, but that is one of my answers. So 33 over 50, answer B is what we're looking for. At the pointy end now, nearly finished. Where is the point 0,4? Well, as I've already started labelling here, we have an x-axis, which is the horizontal one, and a y-axis, the vertical axis. If you think about it, you learn about the number line first. And it was always drawn horizontally. X comes before y. So the horizontal number, that's given by the x. The position vertically relative to the x-axis, whether we're above or below, that's given by the y-coordinate. So what I'm looking for is an x-coordinate of 0. So I go along my x-axis, -5, -4, -3, -2, -1, 0. I must be this on this line when I'm thinking about the horizontal position. And then I need to go up 4. 1, 2, 3, 4. I'm not sure whether you can see that, but that's... Oh, there you go. That looks a little bit better. C must be the point I'm looking for. That's the point that lies at 0, 4. Where's the point -2,4? Again, x, then y. X is my horizontal one, so starting at the origin, I've got to go 2 to the left. Then I have to go up 4. Another easy way to do it, just draw those little things on to remind you. Clearly, point A is at the point -2, 4. Write an expression for the perimeter of this shape. Well, to find the perimeter of any shape, you just find the length of each edge and add them together. Given this is, we're going to assume a rectangle, this opposite side is x, and the opposite side to the long one would also be 2x plus 1. If I want to find the perimeter, I just start at one point and I add all of them up as I go around. So I'd have 2x plus 1. That would get me to the next corner. Then I'd have x. I'll be travelling down, so I've got 2x plus 1, then x, so I'm going to add another x, I'm going to add 2x plus 1 again, and finally, to get back to the start, I have to add another x. Well, collecting all my like terms, I've got 2 x's, plus another one is 3, plus another 2 is 5, plus another one is 6. 6x. What about my numbers? I've got a positive 1, there's another positive 1, so 1 plus 1 is 2. Oh, that's it. 6x plus 2, that's the answer we're looking for there. Question 20, you've made it just about. N is a positive integer. Remember, integers are the positive or negative whole numbers or zeros. So something like -3, -2, -1, 0, 1, 2, 3. The little ellipsis at each end showing these numbers go on forever. There's an infinite number of them. Which of the following numbers is always odd? Well, we know the definition of an even number is that it's got a factor of 2. So An odd number always leaves a remainder of 1 when I'm dividing by 2. If I divide it by 2, there's always 1 left over. So the easiest way to make an even number is to take any integer n, and it says n is our positive integer, and multiply it by 2. That is definitely even. So to get an odd number, that would be anything which is 2n plus or minus an odd number. Now usually we like to keep this as simple as possible, so we'd either add or subtract just 1. You can see which one it'll be now, 2n minus 1. And let's just test it and see if that's always going to be odd. If I start with an odd number, e.g. n equals 5, 2 times 5 minus 1 is 10 minus 1 equals 9. Yep, that's going to be odd. What about if I had n equals 4? That's an even number this time. Would that make any difference? Therefore, 2 times 4 minus 1, 8 minus 1 is 7. Oh yeah, it's still odd. Whether I start with an even or an odd number, if I take 2n and then subtract 1, my answer will always be odd. There you go. Well done on completing the first quiz. Keep up your good work. Make sure you get along to the tutoring sessions on Monday afternoons or Wednesday afternoons if you've got a few questions. Don't forget to ask in Teams. Ask qBot if you're having any trouble with any questions. Of course, you can always check with your teacher, but most importantly, just keep chipping away and doing the work every week. If you do that, you will definitely improve. We're really proud of how our Year 9s have started off the year. Let's keep going in that way, and we'll have a really good year for all of you. Great work. We'll see you in the next video. Bye for now.